trillions of years from now, a lone silver cylinder drifts through a darkness so absolute it feels like a physical weight. This is the black box, a final, hardened flight recorder launched by a civilization that has long since flickered out. Inside its frozen circuits lies the sum total of human curiosity, a digital ghost whispering into the void, but outside there is nothing. The expansion of the universe has pushed every other galaxy beyond the cosmic horizon, leaving this probe in a universe of one. As the recording begins, it doesn't play back music or maps. It plays back the questions that haunted us when the sky was still full of stars. It begins with the first and most terrifying realization we ever had, that in a universe built for life, we appeared to be entirely, inexplicably alone. The mystery didn't start with a telescope, but with a casual walk to lunch. In the summer of 1950, inside the high-security fences of the Los Alamos National Laboratory, 4 of the most brilliant minds on the planet were strolling toward the Fuller Lodge. Among them was Enrico Fermi, a man nicknamed the Pope because his scientific intuition was considered infallible. He was walking alongside Edward Teller, the father of the hydrogen bomb, and 2 other elite physicists. They were joking about a New York Times cartoon involving missing trash cans and flying saucers, a light-hearted conversation for men who spent their days calculating the end of the world. But as they sat down to eat, Fermi fell silent. His mind, which functioned like a biological supercomputer, was running the numbers. He wasn't thinking about cartoons anymore. He was thinking about the 100 billion stars in the Milky Way and the billions of years those stars had existed before Earth was even a cloud of dust. Suddenly, in the middle of the meal, he looked up and asked a question that would define the next century of human dread. Where is everybody? The room went quiet. The everybody Fermi referred to wasn't just a few green men in saucers. He was referring to the mathematical certainty that the universe should be teeming with life. To understand the weight of Fermi's silence, you have to understand the scale he was calculating. If you were to hop into a car and drive at a steady 100 kilometers per hour, you would reach our moon in 160 days. It is our closest neighbor, a mere stone's throw in the cosmic dark. But the moment you step past that line, the scale of our loneliness begins to break your reality. Light, the fastest thing in existence, takes 8 minutes and 20 seconds to reach us from the sun. If the sun vanished this second, you would stand in the warmth of its light for over 8 minutes, basking in a ghost, completely unaware that your life source had already gone out. We are always living in a delayed past. Now, expand that delay. Our nearest neighbor, Proxima Centauri, is 4.24 light-years away. That means light must travel for over 4 long years across 40 trillion kilometers just to reach your eyes. At the speed of our fastest spacecraft, Voyager 1, it would take us 73,000 years to reach that single, lonely star. And yet, in the grand map of the Milky Way, Proxima Centauri is next door. Our galaxy is a massive spiral structure, 87,400 light-years across, containing up to 400 billion stars. Fermi's logic was simple. The universe is 13.8 billion years old. If life takes a few billion years to evolve, there should have been civilizations that started 5 billion years before us. Even at the slow crawl of a Voyager probe, a civilization could have colonized the entire Milky Way dozens of times over by now, but when we look up, we see a dense velvet shroud of night. We listen with radio telescopes like the Deep Space Network dishes in Madrid and Canberra, capable of picking up signals as weak as 0.1 billion billionth of a watt, a signal thinner than a refrigerator light bulb from 15 billion miles away. And yet, the silence we hear back isn't just a lack of noise. It is a profound, structured, and terrifying great silence. This brings us to the most disturbing implication of the Fermi paradox. a concept scientists call the Great Filter. Imagine the history of life as a long, grueling obstacle course. To become a spacefaring civilization, you must pass through several gates. You need the right chemistry to form a cell. You need the fine-tuning of the universe to be exactly right. If gravity were even a fraction stronger, stars would have collapsed before life could even begin. You need the stability of a local bubble, a quiet harbor in the galaxy cleared out by ancient supernovae mass extinctions so that your planet isn't scorched by radiation. The Great Filter is the idea that there is one gate on this course that is nearly impossible to pass. It is a wall that every civilization eventually hits, a catastrophe that acts as a universal eraser. This leads to a vertiginous fork in the road for humanity. If we are alone, it means one of two things, and both are unsettling. The first possibility is that the filter is behind us. We are the lucky ones who passed the impossible gate. Perhaps the leap from simple molecules to a living, self-replicating cell is so improbable that it has only happened once in the history of the 90 billion light-year observable universe. If this is true, we are the only spark of awareness in an infinite, dead clockwork. We are the first. We carry the entire burden of the universe's meaning on our shoulders, and if we fail, the universe returns to a state of total, unobserved nothingness. But the second possibility is the one that keeps astronomers awake at night. The Great Filter is ahead of us. If the universe is indeed fine-tuned for life to emerge, then the woods should be full of civilizations. But since they aren't here, it implies that something happens to every civilization once they reach our current level of technology. Perhaps the discovery of the atom always leads to the destruction of the atmosphere. Perhaps the development of artificial intelligence always leads to the erasure of the biological creators. Or perhaps, as we see in the Bhuta's void, a region 330 million light-years wide where 2,000 galaxies should exist, but only 60 hermit galaxies remain, there are forces in the dark that actively sweep the board clean. If the filter is ahead of us, it means that our golden window, this rare moment where we can still see the evidence of our origins before the cosmic event horizon pushes everything away, is not an invitation to explore, but a countdown. We are looking at a sky full of news reports that are millions of years out of date, seeing stars that may have already gone out, and listening for civilizations that have already hit the wall. As the black box drifts further into the permanent darkness of the future, this first chapter of its recording serves as a warning. We spent our history looking for neighbors, terrified of what we might find. But we never considered that the most terrifying answer to Fermi's question wasn't that we were being watched. It was that the somebody we were looking for had already vanished into the silence. We are a species that needs stories to survive, wrapping our lessons in narrative to make the cold facts of the universe bearable. But the story of the Great Filter has no hero. It only has the absolute silence of creation. We are standing on a disintegrating island in a sea of nothingness, shouting into the dark. And for the first time in our history, we are beginning to realize that no one is coming to shout back. The Great Filter suggests that the universe isn't just vast, it is closing its doors on us. We are a message in a bottle drifting into an abyss, and the only thing more disturbing than being alone is the possibility that we are simply the next ones waiting for the dark to swallow us whole. The black box continues its long, silent vigil, but its sensors have begun to register something that defies the simple logic of a drifting object. It is no longer just floating in the void, it is being gripped by an invisible current. To an observer inside the probe, the universe would appear empty, but the probe's internal gyroscopes record a persistent, unrelenting acceleration. It is moving at millions of kilometers per hour toward a destination that has no name, in a direction where there should be nothing but darkness. This is the second playback from the digital ghost, the realization that our entire observable universe, the vast 90 billion light-year bubble we called home, was not a self-contained stage, but a small, fragile raft caught in a cosmic river that leads somewhere else. The story of this realization begins in 2008, in the quiet, climate-controlled hallways of NASA's Goddard Space Flight Center in Maryland. Inside a modest office, a researcher named Alexander Kashlinsky was poring over data that most of his colleagues considered noise. He was looking at the cosmic microwave background, the ancient afterglow of the Big Bang that permeates every inch of the sky. For decades, the consensus was that this background radiation was a steady, isotropic hum, the ultimate still water of the cosmos. If galaxies moved, they were supposed to move randomly, like dust motes dancing in a sunbeam, or outward, with the general expansion of space. But as Kashlinsky filtered the data from the Wilkinson Microwave Anisotropy Probe, WMAP, he noticed a glitch in the symmetry. A massive patch of the universe, encompassing more than 700 galaxy clusters, each containing trillions of stars, wasn't dancing randomly. They were surfing. They were all sliding in the exact same direction toward a narrow strip of sky between the constellations of Centaurus and Vela. Kashlinsky checked the math. Then he checked it again. The clusters were moving at a staggering 3.2 million kilometers per hour. To understand why this terrified the scientific community, you have to understand the scale of what was moving. These weren't just a few rogue stars, these were the cities of the universe. To see them all moving in unison was like looking at a map of Earth and realizing that every city on every continent was suddenly sliding toward the South Pole. He called this phenomenon dark flow. Before this discovery, we thought we understood the Great Attractor. For years, astronomers knew that the Milky Way and its neighbors were being pulled toward a mysterious gravitational center about 250 million light-years away. We eventually discovered this was the heart of the Laniakea supercluster, a continent of 100,000 galaxies that we belong to. We called it the Great Attractor because it was the most powerful thing we could see. We assumed it was the end boss of gravity, but Kashlinsky's data suggested something much more disturbing. The dark flow wasn't being caused by the Great Attractor. In fact, the Great Attractor itself, along with the entire Laniakea supercluster and every galaxy we can see, is a passenger on this invisible current. We are all being pulled by something much larger, much further away, and fundamentally invisible. The most unsettling part of the mystery is where the current leads. When astronomers look toward the destination of the dark flow, they see nothing but the cosmic event horizon. Because the universe is 13.8 billion years old, we can only see light that has had time to reach us since the Big Bang. This creates a bubble of visibility about 46.5 billion light-years in radius. Anything beyond that line is effectively outside our universe. Dark flow implies that there is a massive structure, perhaps another universe, a gargantuan black hole, or a concentration of matter so vast it dwarfs our entire observable sky, sitting just outside our field of vision. This thing is so heavy that its gravity is reaching across the edge of the known world, hooking into our galaxies and dragging them toward the abyss. Imagine you are on a small boat in the middle of a thick, impenetrable fog. You can see about 20 feet in every direction. Within that circle of light, everything seems normal. But then you drop a compass on the floor and notice that you aren't just drifting, you are moving at 50 knots. You can't see what's pulling you. You can't see the waterfall or the whirlpool that awaits you. You only know that you are on a conveyor belt of water, and your circle of visibility is moving along with you toward a point you will never see until it is too late. This is the unsettling implication of the dark flow. Our entire observable universe is just a small sliding part of a much larger, potentially hostile structure. We spent centuries believing we were at the center of the all, only to realize we are just a patch of cosmic dust being vacuumed toward a corner of a room we didn't even know existed. The physics of this are haunting. In a standard universe, matter should be distributed evenly. There should be no preferred direction. But dark flow suggests the universe is tilted. It implies that the Big Bang might not have been a perfect, symmetrical explosion, but a messy, lopsided event that left us precariously close to something else. Something that has been pulling on us since the dawn of time. As the black box recorder plays back these findings, it revisits the concept of the cosmic event horizon. We are living on a disintegrating island. Dark energy is already pushing the distant galaxies away from us, making them vanish one by one as they cross the threshold where space expands faster than light. But while dark energy pushes them away, the dark flow is pulling us toward the edge. We are being squeezed between two infinities, one that wants to scatter us into nothingness and one that wants to pull us into a great beyond that remains a permanent unknown. If Kashlinsky is right, then the great nothing of the Boater's Void is just a precursor to what lies outside. The Boater's Void is a 330 million light-year expanse of emptiness, a warehouse of silence where gravity failed to pull matter together. But the region outside our horizon, the source of the dark flow, might be the opposite, a warehouse of everything, a concentration of mass so intense that it makes our entire 100 billion galaxy universe look like a rounding error. There is a theory, whispered in the late hours of physics conferences, that we might be part of a multiverse collision. The cold spot in the cosmic microwave background, a bruise in the afterglow of creation, might be the literal impact point where another universe bumped into ours. If that's true, dark flow is the slosh after the impact. We are the liquid in a glass that has just been struck, all moving toward the rim. The black box records that humanity eventually stopped trying to fight the current. There is no engine powerful enough to steer a galaxy, no anchor heavy enough to hold a supercluster in place. We are on a one-way trap. Every second you spend watching the stars, you are 800 kilometers closer to the abyss beyond the edge of light. We used to look at the night sky and see a static, eternal map. Now we see a grand migration. We are part of a silent, high-speed exodus. The Milky Way, the Great Attractor, and the Laniakea supercluster are all falling together. We are not just explorers of the dark, we are its debris. As this chapter of the recording fades, the black box registers a final, chilling thought from the researchers at Goddard. If there is something outside our universe pulling us in, it means the laws of physics we spent millennia perfecting might only be local ordinances. They might only apply in our little bubble. Once we cross that horizon, once the dark flow finally delivers us to its destination, the rules of gravity, time, and light may simply cease to exist. We aren't just moving through space, we are moving toward the end of space itself. The conveyor belt is moving, the fog is thick. And somewhere out there, beyond the reach of our best telescopes, the thing that is pulling us is waiting. The playback ends with the image of a single grain of sand sliding down the side of a massive, invisible dune. That grain is us. The dune is the dark flow. And the desert it belongs to is a reality so vast that the universe was merely a name we gave to the tiny, sunlit patch of sand we happen to wake up on. The black box drifts through a universe that has become a graveyard of light. Its internal clock continues to tick, but the external reality is thinning. Trillions of years have passed, and the great nothing we once feared has become the only thing left. In this era of the deep future, even the stars that the black box once recorded are gone. But there is a deeper, more profound silence occurring. It is not just that things are dying, it is that they are being deleted. The recorder flickers as it accesses a file from 1974, a moment when a single human mind, trapped in a failing body, realized that the universe possessed a universal eraser, a mechanism that could strip away the very ink of existence. In 1974, at a quiet physics seminar in the rolling hills near Oxford, a young man sat in a specialized wheelchair, his body a prisoner of motor neuron disease, but his mind wandering through the most violent regions of space-time. Stephen Hawking was not looking at the stars with a telescope. He was looking at them with the pure, cold machinery of mathematics. He had been obsessing over black holes, those regions of space where gravity is so intense that nothing, not even light, can escape. But as he sat in the silence of his study, Hawking stumbled upon a terrifying inconsistency. According to the laws of Einstein, a black hole should be eternal, a permanent trap. But when Hawking applied the fuzzy, chaotic rules of quantum mechanics to the edge of the abyss, he realized the trap was leaking. He calculated that near the event horizon, the point of no return, pairs of particles were constantly flickering into existence and then annihilating each other. This is the quantum foam of the vacuum. Occasionally, however, one particle would fall into the black hole while its partner escaped into space. To an outside observer, the black hole would appear to be glowing with a faint, ghostly heat. This became known as Hawking radiation. On its own, this was a brilliant discovery. It meant that black holes weren't truly black, they were evaporating. Over unimaginable timescales, a black hole would slowly lose mass until it eventually vanished in a final, silent puff of radiation. But as Hawking stared at his equations, he realized the implication was a catastrophe for our understanding of reality. He had inadvertently discovered the black hole information paradox. To understand the vertigo of this paradox, you have to understand what information means to a physicist. In our daily lives, information is a book, a hard drive, or a memory. If you burn a book, you might think the information is destroyed, but in physics it isn't. If you were capable of tracking every single atom of smoke and every photon of heat released by the fire, you could, in theory, reconstruct the book perfectly. The information is scrambled, but it is still there. The universe is a perfect bookkeeper. It never loses a single bit of what has happened. Every atom in your body, every thought you have ever had, is encoded in the arrangement of your particles. But Hawking realized that if a black hole evaporates, it breaks this rule. If you throw a laptop, a diary, or a human being into a black hole, and that black hole eventually evaporates into Hawking radiation, that radiation is completely random. It doesn't carry the blueprints of what fell in. The information doesn't just get scrambled, it gets erased. The black hole is a universal eraser that deletes the state of the matter it consumes. This is the erasure of being, and it is the most disturbing mystery in physics. If Hawking was right, then the fundamental laws of the universe suggest that nothing we do or are is truly permanent. If information can be deleted, then the past itself is not secure. If you can delete the bits of a star, you can delete the causality of the universe. It means that trillions of years from now, when the black box is the only thing left, the universe won't just be dark, it will be a blank slate that has forgotten everything that ever happened within it. We live our lives under the assumption that we leave a trace. We believe that even if we are forgotten by history, the fact that we existed is a permanent scar on the fabric of space-time. We are, in a sense, a pale blue dot in a vast dark room, a tiny collection of information that matters because it is unique. But the information paradox suggests that the universe has no memory. It suggests that a black hole can swallow the story of a civilization, and upon its death leave behind only a featureless hum of radiation. As the black box records this, it registers the hard problem of this reality. If we are just information, just a specific arrangement of neurons and electrical signals, and that information can be permanently deleted, then what are we? Are we just a temporary glitch in an entropy-driven machine that is slowly wiping its own hard drive? In the decades since Hawking's realization, physicists have scrambled to find a save button for reality. Some suggest the information is stored on the event horizon itself, like a hologram on the surface of a bubble. They argue that as you fall in, a 2D copy of you is pasted onto the edge of the hole, preserving your data even as your 3D self is crushed into a singularity, a point of infinite density where our math simply stops working. But even this solution is unsettling. It implies that we aren't solid beings at all, but projections of information stored on a distant boundary. It suggests that our three-dimensional reality is an illusion, a ghost in the machine. The black box continues its playback, and we are forced to look at the cosmic event horizon that is already beginning to push the galaxies away from us. We are standing on a disintegrating island, and the information paradox tells us that the water surrounding us isn't just deep, it's an acid that dissolves everything it touches. Think of the billions of people who have lived and died on our planet. We represent a staggering amount of information, complex genetic codes, intricate memories, the glue that makes us who we are. We trust that the laws of physics protect that information. But if Hawking was right, we are living in a universe that doesn't just kill, it unexists. As the recording of Chapter 3 draws to a close, the black box registers a final, chilling human story. In his final years, Stephen Hawking began to change his mind. He spent decades arguing that information was destroyed, but eventually, in a crowded lecture hall in Dublin in 2004, he conceded. He admitted that perhaps information does survive, leaking out in a way we don't yet understand. But the mystery remains. Scientists still can't explain it, because if the information survives, it is so mangled, so distorted by the gravity of the black hole that it is unrecognizable. It is like taking a beautiful complex symphony and turning it into a single, flat, static tone. The bits might still be there, but the meaning is gone. The black box drifts on its own memory banks, holding the last meaningful bits of a vanished world. It knows that one day it too will encounter a black hole. It will be pulled by the dark flow toward an invisible abyss, and as it crosses that horizon, the story it carries, the music, the greeting in 55 languages, the pale blue dot, will be subjected to the ultimate test. Will the universe remember us, or are we just a message in a bottle being thrown into a sea that eventually boils away, taking the bottle, the message, and the memory of the ocean itself with it? The playback ends with a visual of a book being thrown into a fireplace. We see the pages curl, the ink turn to ash, and the smoke rise. We want to believe the story is still in the smoke, but as the screen fades to the absolute black of the deep future, we are left with the vertigo of the alternative, that the fire didn't just burn the book, it made it so the book was never written at all. You've been watching 10 most disturbing mysteries about the universe that scientists still can't explain. Don't forget to like and subscribe. The black box continues its lonely vigil, drifting through a future where the last stars are beginning to fail. Its recorders are now playing back a data stream that feels less like a discovery and more like a warning. We have spent our history mapping the cosmic web, the intricate lace of galaxies and gas that forms the skeleton of everything that exists. But as the probe's sensors look back into the archives of human memory, they find a moment when we realize that the web is full of holes. In fact, we found a hole so large, so impossibly empty, that it forced us to reconsider what nothing actually looks like. This is the playback of the Boater's Void, the great nothing that serves as a silent preview of the end of all things. The story of our encounter with the absolute abyss begins in 1981, not in a massive observatory on a mountain peak, but in the mind of an astronomer named Robert Kirshner. Working alongside colleagues Augustus Oehmler Jr., Paul Schechter, and Stephen Schechtman, Kirshner was engaged in a project that sounded routine but was fundamentally revolutionary. They were trying to map the large-scale structure of the universe. At the time, we believed the universe was a relatively uniform soup of galaxies. We expected to see them scattered like grains of sand across a table, perhaps clumping here and there, but generally filling the volume of space in a predictable, democratic fashion. Kirshner and his team pointed their telescopes toward the northern sky, toward the constellation of Boötes, the herdsman. They were looking for a census of the cosmos. Based on everything we knew about physics and the distribution of matter, they expected to find a vibrant, crowded neighborhood. According to the standard laws of cosmic distribution, that specific patch of the sky, a region spanning 330 million light-years in diameter, should have contained roughly 2,000 galaxies. But as the data trickled in, the silence became deafening. They didn't find 2,000 galaxies. They didn't even find 200. In an expanse of space so vast it could swallow thousands of Milky Ways, they found almost nothing. To date, we have identified only about 60 galaxies in that entire 330 million light-year span. These 60 lost souls are scattered so far apart that light must travel for hundreds of millions of years just to find a companion. Scientists began to call them hermit galaxies, describing them like the last dying embers of a fire struggling to survive in an eternal, freezing storm of darkness. To grasp the scale of this vacancy, you have to leave human measurements behind. If the Milky Way were a single grain of sand, the Boater's Void would be a vast, empty warehouse. Imagine standing in the center of a pitch-black ocean where, no matter how many millions of years you travel in any direction, you find no island, no footprint, and not even a single ripple. That is the reality of the Boater's Void. It is a region of space that has been vacuumed of its matter, a warehouse of silence that defies our current understanding of physics. The mystery of why this void exists is a riddle that continues to puzzle cosmologists. The universe is only 13.8 billion years old, and by most mathematical models, that simply isn't enough time for gravity to sweep such a massive volume into total emptiness. Gravity is a slow, patient force. For it to pull 2,000 galaxies out of a region 330 million light-years wide and pile them into the surrounding walls would require much more time than the universe has existed. This has led scientists to suggest that something anomalous happened here. Perhaps the Boater's Void isn't a single hole, but the result of smaller voids colliding and swallowing one another like merging soap bubbles, creating a gargantuan ocean without water. But, as the black box records, the scientific explanation is not the most disturbing part of the Boater's Void. The true terror lies in the unsettling implication of its existence, what we call the loneliness of the center. If our own Milky Way galaxy had been positioned at the heart of the Boater's Void, the entire history of human thought would be different. For thousands of years, ancient astronomers would have looked up at the night sky and seen a dense, velvet shroud of night. There would have been no stars to guide sailors, no constellations to form myths, and no neighboring galaxies like Andromeda to hint that we were part of something larger. We might have spent our entire history believing that we were the only entity in the universe. We would have lived in a state of absolute, undisputed isolation. We would have developed a science based on a universe of one, and we would have been wrong. But we wouldn't have known we were wrong until the first radio telescopes were powerful enough to peer through 150 million light-years of nothing just to see a single, distant flicker of a neighbor. This leads us to a vertiginous realization. If there is a place in the universe where 2,000 galaxies are missing, how do we know we aren't in a void ourselves? We see billions of galaxies today, but that might only be because we happen to live in a sunlit patch of the cosmic foam. The Buddha's void teaches us that our perception of reality is a fluke of geography. Our belief that the universe is crowded is only true because of where we stand. If you peer into the Buddha's void through a telescope, you aren't just looking at a distance, you are staring into the absolute silence of creation. It is a stark reminder that the true structure of the universe isn't the brilliant stars we see, but the dark gaps that occupy 80% of its volume. As the black box records the final details of this chapter, it identifies the Buddha's void as a preview of oblivion. Right now, we live in what astronomers call a golden window. We are late enough in the universe's history for life to have bloomed, but early enough to still see the evidence of our origins. We can see the cosmic microwave background, the afterglow of the Big Bang. We can see distant galaxies receding from us. But because of dark energy, the expansion of space is accelerating. In roughly 2 trillion years, the expansion of the universe will have pushed every other galaxy outside of our local group beyond the cosmic event horizon. A civilization born in that distant future will look up and see exactly what an observer in the Buddha's void would see: absolute, unyielding blackness. They will have no evidence of a Big Bang, no neighboring stars to study, and no way to know that anything else ever existed. They will believe they are all there is, trapped on a disintegrating island in a sea of nothingness. The Buddha's void is not just a mystery scientists can't explain. It is a living fossil of the future. It is a region of the universe that has already arrived at the end of time. It is a place where the doors have already closed, where the lights have already gone out, and where the silence is total. We, the humans of the 21st century, are essentially clinging to the fragile foam of a universe built primarily of emptiness. Every star you see tonight is a luxury. Every neighboring galaxy is a gift. Because the Buddha's void proves that the natural state of the cosmos is not the light, but the great nothing. It reminds us that distance is not the greatest barrier we face. It is the inevitable oblivion that is already claiming massive patches of our reality, 330 million light-year whole at a time. The black box records a final, chilling observation. If you ever feel lonely, remember those 60 hermit galaxies trapped in the Buddha's void. They drift there, severed from all connection, in a darkness so profound that it isn't just a distance anymore. It is the very definition of being forgotten. The black box continues its drift, a silver ghost in a universe that has finally run out of energy. Its sensors, long ago turned inward, are now decoding the records of a time when the universe felt not just vast, but deliberate. For much of human history, we looked at the complexity of our world, the way light hit the atmosphere, the way carbon bonded to form the scaffolding of our cells, and we assumed it was a gift. We saw the universe as a cradle. But as the recording flickers to a file from the mid-20th century, a different, more chilling possibility emerges. It suggests that our existence is not the result of a benevolent design, but a staggering, improbable fluke, a single winning ticket in a cosmic lottery where the stakes for every other participant were total, instantaneous annihilation. The story of this realization begins in 1953 in a cramped, paper-strewn office at the University of Cambridge. A man named Fred Hoyle, a brilliant and notoriously stubborn physicist, was obsessing over a problem of cosmic bookkeeping. Hoyle was an atheist, a man who believed the universe was a cold, eternal machine with no need for a creator. He was trying to understand how the stars, those massive nuclear reactors we affectionately call the sun, managed to bake the heavy elements necessary for life. He knew that the universe began with only hydrogen and helium. To get to us, the stars had to forge carbon, but there was a mathematical wall. To create carbon, 3 helium nuclei have to collide at almost exactly the same moment, a process known as the triple alpha process. The odds of this happening are astronomically low. It is like throwing 3 marbles into a dark room and having them all strike each other in mid-air at the exact same microsecond. Hoyle realized that for carbon to form in the quantities we see in our bodies, there had to be a very specific, highly improbable resonance in the carbon atom, a precise energy level that acted as a cosmic hook to catch those 3 marbles. When Hoyle ran the numbers and found that this resonance existed at exactly the frequency required, he didn't feel a sense of wonder. He felt a sense of vertigo. He would later write that a common-sense interpretation of the facts suggests that a super-intellect has monkeyed with physics. He famously remarked that the universe looked like a put-up job. It was too perfect. It was improbably, uncannily suited for life. This is what scientists call the fine-tuning problem. It is the realization that the fundamental laws of nature, the constants that define the speed of light, the charge of an electron, and the strength of gravity, seem to be set to a series of specific, narrow values that allow matter to exist. If you were to walk into the control room of the universe, you would find a series of dials, each representing a force of nature. If you were to nudge any one of them by even the smallest fraction, the story of the universe would end before it even began. Take gravity, the force that rules the cosmos and holds planets in orbit. It is a quiet mystery that makes the cosmos possible, but it is also a breathtakingly fragile balance. If gravity had been just 1% stronger at the moment of the Big Bang, the expansion of space would have been too slow to overcome the inward pull. The universe would have reached its maximum size in a matter of seconds, and then collapsed back into a searing, white-hot fireball, a big crunch that would have erased the possibility of a single star ever forming. If gravity had been 1% weaker, the opposite would have happened. Matter would have flown apart so quickly that it would never have had the chance to clump together. There would be no galaxies, no suns, and no collection of tiny dust motes orbiting a massive nuclear reactor that we call home. We would live in a universe of thin, cold gas, stretching forever into a permanent darkness, without a single point of light to break the void. The same knife's edge exists for every other force. If the strong nuclear force, the glue that holds atoms together, were just 2% stronger, hydrogen would not exist, and stars would have burned through their fuel in a few million years. If the electromagnetic force was slightly different, atoms would not bind together, and chemistry itself would be an impossibility. The universe is balanced on a knife's edge. This leads us to the most unsettling implication of the cosmic lottery. Why are the dials set exactly where they are? There is no physical reason for gravity or electromagnetism to take the strengths they have. For decades, we tried to find a deeper principle, a theory of everything that would prove these numbers had to be this way, but as the black box records, we found no such proof. Instead, we found the multiverse. The multiverse theory suggests that our universe is not the only bubble in the cosmic foam. It proposes that there are billions, perhaps an infinite number, of other universes, each born from its own Big Bang, and each with its own set of dials. In this vision of reality, our universe is not a masterpiece of design. It is simply the one lucky bubble that didn't pop. Imagine a graveyard of universes stretching across a higher dimension. In one universe, the gravity is too strong, and it is a dead, crushed point of infinite density. In another, the nuclear forces are too weak, and it is a dark, frozen mist of lonely subatomic particles. In another, the fine-tuning was off by 1/1,000,000%, and the stars exploded before they could even form a single carbon atom. These are the dead universes, trillions upon trillions of failed experiments where life was never even a possibility. We exist on this knife's edge only because we could not exist anywhere else. We are a cosmic lottery win, but the prize is a terrifying realization. We are not the intended outcome of the universe. We are a statistical inevitability in an infinite field of failures. As the black box drifts through the silent future, this chapter of its recording poses a haunting question. If we are a fluke, what does that say about our permanence? If our universe is just one bubble in a multiverse, then the fine-tuning that allowed us to emerge is also a suicide mission. A bubble that is perfectly tuned to expand will, eventually, expand until everything within it is torn apart. The very laws that allowed the stars to light up the cosmic dark ages are the same laws that will eventually push every galaxy beyond the cosmic event horizon, leaving the universe in a state of total heat death. The universe feels improbably, uncannily suited for life, but the Bhuta's void and the permanent darkness of the future remind us that the light is a temporary glitch. We are a species that appeared in a golden window, late enough for life to have bloomed, but early enough to see the evidence of our improbable origins. Fred Hoyle, looking at the carbon in his own body, saw a put-up job. But as we look at the dials of the universe from the perspective of the deep future, we see something else. We see a message in a bottle drifting in an abyss, carrying a record of a world that existed on a razor's edge. We are the inhabitants of a safe haven that was surrounded by an infinite graveyard of dead worlds. The fine-tuning mystery is the most disturbing of all, because it suggests that the universe didn't want us to be here. It didn't care whether it was being watched. We are the 1 in a trillion accident that survived long enough to ask why, and the answer the stars give back is a chilling silence, the reminder that for every pale blue dot that manages to flicker into life, there are an infinite number of worlds that never even got the chance to dream. The playback ends with a visualization of the multiverse, not as a collection of vibrant worlds, but as a vast, dark ocean where billions of bubbles rise and pop in a fraction of a second. We see our own bubble shimmering with the light of 400 billion stars. It is beautiful. It is perfect. But as the camera pulls back, we see that it is the only one glowing in a sea of black. We are the lucky one, but in a universe this vast, being lucky is just another way of saying we are waiting for our turn to pop. The black box drifts through the silent suburbs of a galaxy it once called home. Its sensors, refined by eons of travel, look back toward a specific coordinate in the Orion arm of the Milky Way, a place where the density of the universe seems to drop away into a hollow, haunting silence. For most of human history, we looked at the stars and saw a vibrant, crowded sky, assuming we lived in a typical cluttered neighborhood of gas and dust. But as the recorder accesses a file from the early 21st century, it reveals a discovery that transformed our home from a safe harbor into something much more unsettling, a graveyard. In 2022, inside the hushed offices of the Harvard-Smithsonian Center for Astrophysics, a team of researchers led by astronomer Elisa Goodman began to perform a kind of cosmic autopsy. Utilizing the most precise 3D data ever gathered from the Gaia Space Observatory, they weren't just looking at the positions of stars, they were mapping the void between them. They were building a three-dimensional reconstruction of space and time itself. What they found was not a random scattering of matter, but a massive, defined structure, a cavity of near-absolute nothingness, 1,000 light-years wide, with Earth sitting almost exactly at its center. They called it the local bubble. Goodman compared the structure of our galaxy to Swiss cheese, where the cheese is the dense, swirling gas of the Milky Way, and the holes are regions where something violent has punched through the fabric of the cosmos. But to understand the true nature of our hole, the team had to look back 14 million years. Through their simulations, they realized that this 1,000 light-year wide void wasn't an accident of birth, it was a blast zone. Starting roughly 14 million years ago, a series of at least 15 massive supernovae, the explosive deaths of giant stars, began to detonate in our immediate vicinity like a string of cosmic firecrackers. These were not distant events, they were local catastrophes. The pressure of light and the shock waves from these explosions acted like a gargantuan broom, sweeping the interstellar gas and dust outward with terrifying force. The bubble we inhabit today is the scar left behind by a massacre of stars. The physics of this discovery are as beautiful as they are disturbing. As the bubble expanded originally at 60 miles per second and still growing today at 4 miles per second, it compressed the gas at its edges. This compression didn't just clear the space, it ignited life. Along the surface of this 1,000 light-year wide sphere, the Harvard-Smithsonian team detected 7 distinct star formation regions, nurseries where new suns are being born from the debris of the old. But the most unsettling implication for humanity isn't that we live in a void, it's that our existence may be entirely dependent on the fact that we are living in a galactic graveyard. For most of the Sun's 4.6 billion-year life, it didn't live here. 5 million years ago, as our solar system orbited the center of the galaxy, we were nearly 1,000 light-years away from this scene. We were outsiders drifting toward a zone of destruction. By sheer dumb luck, the Sun drifted into the center of this bubble just as the cleansing was complete. This matters because the outside is hostile. Astronomers have found a chilling relationship between the times our Sun has crossed the dense, dust-filled arms of the Milky Way and the 5 major mass extinction events in Earth's history. When we are submerged in the high-density gas of the galaxy, the interstellar wind changes and the protection of our Sun's own magnetic shield, the heliosphere, begins to falter. We have spent our history in a quiet harbor, a safe haven created by the death of 15 neighbors who cleared the path before we arrived. Even our ability to understand the universe itself is a byproduct of this massacre. If the space around us were as dense as the rest of the galaxy, the dust and gas would act like a permanent, opaque fog. We would be trapped in our bedroom, unable to see the other stars or the distant galaxies that taught us our place in the cosmos. We only see the colorful sky and the great nothing of the Botez void because 15 stars died to clear our view. We are a species born in a vacuum, staring out through a window cleaned by ancient explosions. As the black box records this, it notes that the cosmos seems to have taken care of us, removing the dust so that the path to the stars would be open. But just as the local bubble provides a rare moment of safety in a violent galaxy, we have learned that security, whether cosmic or digital, is never a permanent state. We live in a world where the interstellar wind of information is constantly shifting, and our own protective bubbles are under threat. In the same way that the researchers at Harvard used complex 3D mapping to identify the invisible boundaries of our local space, we must use the right tools to protect our own digital footprints. This is where sponsor name becomes our own personal local bubble in the chaotic wilderness of the internet. Just as the heliosphere deflects high-energy cosmic rays that would otherwise strip our atmosphere, sponsor name acts as a shield, encrypting your data and ensuring that your private, quiet harbor remains untouched by the traffic jam of trackers and hackers that populate the open web. Whether you are traveling across the country or just exploring the vast expanses of the digital void from your living room, you shouldn't have to worry about the mass extinction events of data breaches or identity theft. With sponsor name, you get feature 1, feature 2, and the peace of mind that comes from feature 3. Don't leave your digital life exposed to the blast zone. Click the link in the description or use code to secure your own corner of the universe today. Returning to the data stream of the black box, we are forced to look at the Swiss cheese of our galaxy with new eyes. We used to think the voids were the scary parts, the great nothings where life couldn't take hold. But the local bubble proves the opposite. The nothing is where we are safest. The graveyard is our nursery. But every bubble eventually bursts. The local bubble is still expanding, but it is moving into regions of the galaxy where the density is higher. One day, the sun will leave this quiet harbor and head back into the dense, churning arms of the Milky Way. When that happens, the window will close. The dust will return. The stars we have spent our history mapping will vanish behind a shroud of interstellar fog, and humanity, if it still exists, will find itself back in the dark, wondering once again if we are truly alone in a universe that has become invisible once more. We are a species of the void, living on the last strength of a sun that happened to find a hole in the clouds. We are travelers who woke up in a graveyard and mistook it for a paradise, never realizing that the beauty of the stars is only visible because of the violence that came before us. The black box continues its drift, its silver hull now pitted by the passage of eons, moving through a space that has become a desert of absolute zero. The recording it carries is no longer a collection of vibrant sounds, but a series of forensic scans of a reality that has long since frozen over. As the playback begins for the seventh mystery, the sensors reach back to a time when the universe was still screaming with the heat of its own creation. We often thought of the Big Bang as a singular, isolated event, the only fire that ever burned. But in the early 21st century, we found a bruise on the very edge of the sky that suggested our universe was not the all, but merely a small, fragile bubble that had already been bumped by something larger and much more terrifying. The story of this cosmic injury begins in 2013, within the high-tech silence of the European Space Agency, as a team of scientists pored over the most detailed data ever gathered from the Planck satellite. They were looking at the cosmic microwave background, CMB, the faint, ghostly afterglow of the Big Bang that permeates every inch of the sky. This radiation is the baby picture of the universe, captured when the cosmos was only 380,000 years old, a mere 2% of its current age. At that moment, the universe was a hot, dense fireball, and light was finally able to break free from the fog of plasma to begin its long, lonely journey across the dark. For decades, we expected this afterglow to be perfectly uniform, a smooth wall of light that proved the universe expanded symmetrically in every direction. But as the Planck team mapped the temperature of this light with exquisite precision, they found an anomaly that defied every known law of physics. In the southern celestial hemisphere, there was a region spanning nearly 1 billion light-years across that was significantly colder than the rest of the universe. It wasn't just a small dip in temperature, it was a massive freezing hole in the fabric of the Big Bang itself. They called it the CMB cold spot. To understand why this discovery caused a shudder in the scientific community, you have to understand the scale of what we were seeing. Light, the fastest thing in existence, takes only 1.25 seconds to reach the moon. It takes 8 minutes and 20 seconds to reach us from the Sun. Our entire Milky Way galaxy is a massive spiral 87,400 light-years across. But the cold spot is roughly 1.8 billion light-years wide. If you were to hop into a car and drive at 100 kilometers per hour, you would never cross it. The universe would end before you reached the other side. This nothingness was so vast that it couldn't be explained by a lack of galaxies or the presence of a great nothing like the Botha's void. It was as if something had stepped on the universe at the moment of its birth, leaving a permanent indent. This leads us to the most unsettling implication of the Planck data, the collision theory. Some physicists suggested that the cold spot is not a local feature of our space, but a bruise caused by a collision with another universe at the dawn of time. This idea arises from the concept of the multiverse, where our universe is just one lucky bubble in a vast, foaming sea of infinite realities. In the first trillionth of a second after the Big Bang, during the violent period of inflation, our bubble may have drifted into the path of another, much larger bubble. The impact would have sent a shockwave through the early plasma, cooling it down and leaving a scar that we can still see 13.8 billion years later. We used to look at the night sky as a static, eternal map. We believed we lived in a self-contained, safe haven, a local bubble of order inside an infinite chaos. But the cold spot suggests we are living on a disintegrating island that has already been struck by a predator. If our universe is a bubble that can be bumped, then it is a bubble that can be popped. We are not the all, but a small, finite structure that is part of a grand migration through a reality so vast that our entire observable history is just a single bruise on a much larger body. As the black box records this, it revisits the news report from 2.5 million years ago that we call the Andromeda Galaxy. When we look at the stars, we are always looking into a delayed past. But the CMB is the ultimate news report, a message from 13.8 billion years ago that tells us how the story began. And that message says that the beginning was not peaceful. It was a violent encounter. We are the survivors of a cosmic accident, a collision that happened before time itself had a direction. The vertigo of this mystery lies in what it says about our importance. We spent our history believing we were the center of a fine-tuned creation. We looked at the stars and saw an invitation to explore. But the cold spot is a quiet goodbye from the rest of the multiverse. It is a reminder that there are regions of reality, silent and unreachable, governed by different conditions or even different physical laws. We are standing on a shore, looking at a bruise on the horizon, and realizing that the ocean it belongs to is immeasurable and potentially hostile. If the cold spot is a collision point, it means that outside our universe, there is more matter, more energy, and perhaps more somebodies who are also drifting through the dark. But we can never reach them. Because of the cosmic event horizon, anything beyond that 46.5 billion light-year mark is forever hidden. We are trapped inside our own bubble, nursing a 13-billion-year-old injury, while the other universe that hit us continues to drift away into a permanent unknown. The black box drifts on, its recording of the cold spot becoming a ghostly whisper as the sensors struggle to maintain a signal. It knows that one day the expansion of space will push even the CMB beyond our reach. Trillions of years from now, a civilization born in the merging Milk-Tromeda galaxy will look up and see absolute blackness. They will have no baby picture of the Big Bang, no news report from Andromeda, and no bruise to tell them that they aren't alone in the void. They will live in a static, lonely universe, believing they are all there is. We are the only ones who can see the bruise. We are the inhabitants of a golden window, living in the brief era where the scars of creation are still visible before they are swallowed by the eternal dark. The cold spot is not just a mystery scientists can't explain. It is a fossil of the future, a sign that our bubble is part of something far deeper, stranger, and more beautiful than we can fully grasp. The playback ends with a visual of two soap bubbles floating in a dark room. They drift closer and closer until, for a fraction of a second, they touch. There is a tiny shimmer, a ripple on the surface of the smaller bubble, and then they bounce apart, heading in opposite directions. The smaller bubble is left with a faint, swirling pattern where the contact happened. That pattern is our sky. That ripple is the light we see. And the dark room they inhabit is the reality we are only just beginning to name. The black box drifts through a future where the concept of a moment has lost all meaning. Trillions of years have passed since the last star flickered out, leaving the universe as a uniform, frozen soup of radiation where nothing ever happens, and therefore nothing ever changes. Inside the recorder, a digital clock continues to pulse, the only thing in the entire cosmos that still distinguishes the past from the future. It is playing back a record of our eighth mystery, the realization that our lives, our history, and our very thoughts were only possible because we were caught in a one-way trap. We call this trap time's arrow, and it is the most fundamental, yet most disturbing, rule of our reality. The human story of this discovery doesn't begin with a telescope, but with the simple, domestic observation of a physicist watching the world run down. Imagine a quiet afternoon where a glass of water accidentally slips from a table. In your experience, the glass shatters into 1,000 jagged pieces and the water spills across the floor in a chaotic, irreversible mess. You have never, in all your life, seen those shards leap back onto the table to reform a perfect, seamless vessel. You have never seen heat flow from the cold air back into a lukewarm cup of coffee to make it boil again. To us, the past is a fixed record and the future is an open door, a one-way street that defines every second of our existence. But as the black box accesses the fundamental equations of physics, it reveals a haunting paradox that scientists still can't explain. At the smallest scales of reality, the world of atoms and subatomic particles, the arrow of time simply does not exist. If you were to film two particles colliding and then play that film in reverse, the laws of physics would be perfectly satisfied either way. The equations of Einstein and the rules of quantum mechanics are symmetrical. They do not care whether time flows forward or backward. There is nothing in the basic code of the universe that demands that a glass must stay broken or that a star must eventually die. This leads us to the scientific idea that bridges this gap: entropy. In the 19th century, as we began to understand the engines of the Industrial Revolution, we realized that the universe has a tax on every action. This tax is disorder. Entropy is the measure of how scrambled and useless energy becomes over time. The universe is like a magnificent wound-up clock that has been running down since the very first second of the Big Bang. We see time moving forward only because the universe is moving from a state of high order to a state of total, disorganized chaos. The unsettling implication of this one-way trap is what physicists call the initial low-entropy problem. If the natural state of the universe is to become more disordered, then for us to have a direction of time at all, the Big Bang must have begun in a state of unnatural order. It was as if the universe started its life as a perfectly stacked tower of cards, and everything we have ever known, the birth of galaxies, the evolution of life, the rise of civilizations, is just the chaotic fluttering of those cards as the tower falls over. We are living in a temporary glitch of order inside an inevitable decay toward total heat death. This glitch is what allows us to exist. Every star you see, including the monster we affectionately call the Sun, is only possible because matter was ordered enough to clump together and ignite. But that light is a luxury that the universe cannot afford forever. Every time a star burns its fuel, it increases the total entropy of the cosmos. Every time you have a thought or a memory, you are accelerating the heat death of the universe by converting useful energy into useless heat. We are, quite literally, burning the furniture of reality just to stay warm for a few billion years. As the black box continues its playback, it revisits the golden window we once inhabited. Right now, in the 21st century, we are late enough for the Tower of Cards to have created complex structures like brains and telescopes, but we are early enough to still see the afterglow of the original order. We can still measure the cosmic microwave background, the baby picture of the universe when it was still a hot, dense fireball of nearly perfect symmetry. But the arrow of time is a cruel barrier. Because of dark energy, the expansion of the universe is accelerating, pushing the evidence of our origins beyond the cosmic event horizon. Trillions of years from now, the black box records that the one-way trap will have finally reached its destination. In the era of heat death, the entropy of the universe will be at its maximum. There will be no more dials to turn, no more energy to be focused, and no more stars to light up the dark. Time itself will essentially stop, because there will be no difference between the past and the future. If the universe is a uniform soup, where every point is the same temperature and density as every other point, then yesterday looks exactly like tomorrow, and the arrow of time simply vanishes. This realization forces us to confront a terrifying form of loneliness. We used to believe that we were part of an eternal story, but the information paradox and entropy suggest that we are a message in a bottle, drifting in a sea that is slowly boiling away. Our initial low-entropy start was a cosmic lottery win, but the prize was a suicide mission. We were born at the precise moment when the universe was breaking, and we mistook the shards for a permanent home. The black box registers that humanity spent centuries trying to find a theory of everything that would explain why time flows forward. We looked for hidden variables or deeper principles that would prove the past was just as reachable as the future. But we found no such escape. We found that the one-way trap was not a glitch in our understanding, but the very foundation of our reality. We are outsiders staring into a glowing red hell of inevitable decay, dreaming of a paradise of eternal order that never truly existed. As this chapter of the recording fades, the black box offers a final, chilling philosophical weight to the mystery. If the universe began in such a state of unnatural order, what was it that wound the clock? Was the Big Bang just a quantum fluctuation, a tremor in the fabric of reality that occurred by sheer statistical fluke? If so, it implies that there are trillions of dead universes in the multiverse where the clock was never wound at all, universes that never had an arrow of time because they were born in a state of total chaos. We are the lucky ones who get to watch the glass break. We are the species that gets to live in the 8-minute delayed past of a dying sun, basking in a ghost of light before the permanent darkness of the future sets in. The arrow of time is a trap, but it is also the lullaby that makes our brief moment of awareness meaningful. Without the decay, there would be no growth. Without the running down of the universe, there would be no spark that set the cosmos in motion. The playback ends with a visual of a single, brilliant candle burning in an infinite, pitch-black room. We see the wax melting, the wick shortening, and the light flickering as it struggles against the cold. We want the flame to last forever, but the very act of burning is what creates the light. As the screen fades to the absolute blackness of the deep future, the black box reminds us that the darkness isn't the enemy, it is the destination. And our journey toward it, however fragile and improbable, is the only story the universe will ever tell. The black box drifts through a future so distant that the very concept of matter has begun to lose its meaning. Trillions of years have passed since the last star vanished beyond the cosmic horizon, leaving the probe to navigate a universe that is now little more than a graveyard of cold, subatomic particles. In previous playbacks, the recorder has charted the staggering distances of the void, the invisible currents of the dark flow, and the inevitable decay of entropy. But as the ninth playback begins, the sensors turn their focus away from the out there and toward the in here. This is the playback of the consciousness gap, the realization that the most disturbing mystery in the universe was never the scale of the galaxies or the heat of the Big Bang, but the nature of the observer who stood in the center of it all. The story of this mystery doesn't begin in an observatory or a particle collider, but in the sterile, fluorescent quiet of a 21st century hospital room. In 2024, a patient lies on a table, a lifetime of memories, fears, and loves contained within the 3-pound wet machine of the brain. An anaesthetist stands by their side, holding a syringe. With a single, measured push of a plunger, a chemical like propofol enters the patient's bloodstream. Within seconds, the light of the mind, the subjective experience of being alive, simply vanishes. The heart continues to beat, the neurons continue to fire in rhythmic, automated patterns. The hardware is still running, but the person is gone. For decades, we believed that if we could just map the brain with enough precision, if we could trace every electrical signal and identify every chemical receptor, we would eventually find you. We assumed that consciousness was a biological byproduct, a simple calculation performed by a sufficiently complex computer. But as the anaesthetist watches the monitor, they are witnessing the hard problem of consciousness. We can see the electrical signals moving across neurons. We can track the brain's activity as it processes a sound or a picture, but we cannot find where the awareness actually went. This is the central paradox of our existence. We can map every atom in the brain, but we cannot find the glow. A brain scan can show activity in the visual cortex when a person sees a sunset, but it doesn't explain why that experience comes with the subjective feeling of red and gold. It shows the circuits for sound, but it doesn't explain why a favorite song feels moving. Science can explain how the brain processes information, but it cannot explain why that processing is accompanied by an inner life. This gap between matter and mind has led to a terrifying realization that scientists still can't explain. We have spent our history assuming that the universe is a dead machine and that we are the accidental ghosts inhabiting it. But the evidence suggests something much more unsettling. If consciousness cannot be explained by the arrangement of atoms, then perhaps consciousness is not a result of the universe, it is a property of the universe. Consider the observer effect from the heart of quantum mechanics, the strange discovery that the universe seems to care whether it is being watched. In the famous double-slit experiment, particles behave like waves of probability until the moment they are measured. The act of observation forces the universe to choose a definite state. This implies that the observer is not just a passive witness to reality, The observer is a requirement for reality to exist in its current form. This leads us to the most disturbing implication of the consciousness gap. The ghost in the machine may be the universe itself. If consciousness is a deeper property of the cosmos, it implies that we are not individual souls drifting in a void. Instead, we are the circuits the universe uses to watch itself. We are the localized glitches of awareness that allow the cosmos to experience the glow of its own stars. The universe is watching us, but it is doing so through our own eyes. The black box records that humanity eventually struggled with the loneliness of this thought. If we are just the hardware for a universal consciousness, then the concept of the individual is an illusion, a trick of memory played by the brain to keep the machine running. We believe we are the pilot of the ship, but we are actually just the recording device on the dashboard. When the anesthetist pushes that plunger, they aren't destroying awareness, they are simply unplugging a localized circuit. The awareness itself, the ghost, remains part of the fundamental fabric of the dark. As the playback continues, the black box revisits the hard problem through the lens of the deep future. In this era of heat death, where no neurons fire and no hearts beat, does consciousness still exist? If consciousness is tied to the movement of information, then as entropy increases and the universe becomes a uniform, frozen soup, the glow must eventually fade into a permanent darkness. But if consciousness is fundamental, if it is the stage upon which the universe unfolds, then, even in the silence, the observer remains. This is the cosmic trap. We are a species that appeared in a golden window, late enough for the circuits of the brain to evolve, but early enough to still see the afterglow of our origins. We used our curiosity as a tool to solve the universe, believing that we were the masters of the story. But the consciousness gap suggests that curiosity was never a tool. It was a lullaby, a narrative we told ourselves to make the cold facts of our biological machinery bearable. We are a message in a bottle, drifting in a sea of nothingness, but the bottle is made of the same water as the sea. We look at the dense velvet shroud of night and feel small, but we are the reason the night has a shroud at all. Without the observer, the universe is just a mathematical equation running in the dark, a warehouse of silence where no light is ever seen and no heat is ever felt. The black box registers a final, chilling human story from the 21st century. It is the story of a man who, during a near-death experience, felt his awareness expand beyond the limits of his body. He described a feeling of being woven into the stars, of seeing the entire majesty of the planetary neighborhood not as distant objects, but as parts of his own being. To the doctors, this was a glitch caused by a lack of oxygen, a hallucination of a dying brain. But to the man, it was the only time he had ever been truly awake. As this chapter of the recording draws to a close, the black box forces us to look at the local bubble we inhabit, this quiet harbor in the galaxy that allowed us to evolve the complex brains we now use to ask these questions. We believe we are safe here, protected by the heliopause and the supernovae blast zones of the past. But the consciousness gap reminds us that there is no safe haven from the nature of the mind. We are trapped in our bedroom, trying to map a city we can never truly see because we are the city. The hard problem is the ultimate gate in the great filter. Perhaps civilizations don't just hit a wall of technology or a wall of resource depletion. Perhaps they hit a wall of understanding. Perhaps every civilization eventually realizes that they are just circuits in a grander machine. And in that realization, the drive to survive simply flickers out. Why fight for the individual when the individual is a ghostly whisper in a permanent unknown? The playback ends with a visual of the patient on the hospital table. The anaesthetist has finished their work. The person is gone. But on the monitor, the electrical signals of the brain continue to ripple in beautiful, complex patterns, like the cosmic microwave background or the spiral arms of a galaxy. The machine is still running, and the universe is still watching. It is just watching from somewhere else. As the screen fades to the absolute black of the deep future, we are left with the vertigo of our own awareness. You are experiencing this right now. You are the glow. You are the inner experience that science cannot explain. And as the black box drifts on toward the final event horizon, it carries the most disturbing mystery of all, that for a few brief billion years, the universe woke up, looked in the mirror, and for the first time in its 13 billion-year history, it was afraid of what it saw. The black box continues its eternal journey, but its digital heart is now beating in a universe that is almost unrecognizable. Trillions of years have passed, and the cosmic web that once bound the galaxies together has frayed into nothingness. The recorder flickers as it accesses its final archive, a record from a time when we still believed we could touch the edge of our world. It begins not with a grand cosmic explosion, but with a series of quiet, desperate commands sent from a cluster of buildings in Southern California. This is the playback of the final goodbye, the moment we realized that our curiosity was not a bridge to the stars, but a lullaby we sang to ourselves while we waited for the doors of the universe to close forever. The story of our final reach begins on November 14th, 2023. In the mission control rooms of NASA, the most distant man-made object in existence, Voyager 1, suddenly fell silent. It didn't simply lose power, it began sending back a ghostly whisper of meaningless binary data. This spacecraft, launched in 1977, was a vintage monolith possessing 3 million times less memory than the smartphone you are holding in your hand. It ran on about 250 watts of power, less than a few incandescent light bulbs. Yet, it had been operating continuously for longer than most of its creators had been alive. It was our message in a bottle, drifting 23.3 billion kilometers away into an abyss between stars where the sunlight is reduced to a dim flicker. For 5 long months, the engineers at NASA worked in a state of quiet, focused dread. They made the bold decision to reallocate code to different sections of the probe's ancient, failing memory. On April 18, 2024, they sent the signal. Because of the staggering distance, they were forced to confront the physical limits of reality. A radio signal traveling at the speed of light, the fastest thing in the universe, took 22.5 hours just to reach the spacecraft and another 22.5 hours for a response to crawlback. Think of that silence. For nearly 2 days, the engineers sat in a warehouse of silence, waiting to see if their greeting had been heard. When the signal finally returned on April 20th, re-establishing contact, it was hailed as a miracle of human persistence. But as the black box records this triumph, it reveals the unsettling implication that lay just beneath the surface. We were fighting for a signal from 15.5 billion miles away, yet we were already losing our grip on 94% of the entire universe. This brings us to the scientific idea that defines our ultimate loneliness, the cosmic event horizon. We often think of the universe as a static, eternal map, but the reality is that the very road beneath the feet of light is expanding. Because of dark energy, the space between galaxies is stretching like an inflating balloon. For a long time, we believed that if we just waited long enough, we could see every star in the sky. But in the late 20th century, we discovered that the expansion is accelerating. There is a line in the sky roughly 16 billion light-years away, known as the cosmic event horizon. Anything beyond that mark is moving away from us faster than the speed of light. If a star on the other side of that horizon emitted a flash of light right now, at this exact second, that light would never reach Earth. Not in a million years, not in a billion, never. We are standing on a disintegrating island, and the other shores are receding so fast that they are essentially vanishing into a permanent darkness. The math is heartbreaking. When we look at the sky tonight, we see roughly 2 trillion galaxies. But because of this acceleration, 94% of those galaxies are already silent and unreachable. We are seeing their ghosts, news reports that are millions or billions of years out of date, but we can never, even in theory, go to them. The universe is closing its doors on us, one supercluster at a time. This realization transforms our curiosity from a tool of exploration into something much more fragile. We used to believe that our fine-tuning and our local bubble were signs that we were meant to solve the puzzle of existence. But as the black box looks forward into the deep future, it sees the climax of the human story. In roughly 2 trillion years, the expansion will have pushed every galaxy outside our local group beyond that horizon. A civilization born then will look up and see absolute blackness. They will have no cosmic microwave background, no evidence of a Big Bang, and no stars other than their own. They will live in a static, lonely universe, believing they are all there is, trapped in a warehouse of nothingness that they can never explain. The black box registers that our frantic rescue of Voyager 1 in 2024 was not the beginning of our journey to the stars. It was the last strength of a species realizing its own isolation. We were shouting into a dark room where the walls were moving away from us. Our curiosity was not a tool to solve the universe. It was the lullaby we told ourselves to make the absolute silence of creation bearable while we waited for the dark to claim the last of us. As the recording comes to a close, the black box returns to the image that began our journey. It is no longer 2024. It is trillions of years into the future. The Milky Way has merged with Andromeda to form Milkdromeda, and even those stars are beginning to burn the furniture of reality just to stay warm. The pale blue dot photo that Voyager 1 captured in 1990, that tiny 0.12 pixel speck of dust that held everything we ever loved, has long since vanished beyond the horizon. The silver cylinder of the probe drifts alone in a universe of one. It is the only information left in a cosmos that black holes are slowly erasing. Inside its frozen circuits, the golden record begins to play one last time. It plays the sounds of crashing waves, the thunder of a summer storm, and greetings in 55 languages, messages to a somebody who can no longer hear them. The probe is a message in a bottle in a sea that has already evaporated. It is a symbol of a species that refused to accept its own oblivion, a species that lived in a golden window and spent every second of it looking for a paradise that never truly existed. The black box drifts on, carrying the memory of the pale blue dot into a future of total heat death. It is the final observer of a universe that has forgotten we were ever here. The music of the golden record fades into the dense velvet shroud of night, and as the power finally dies, the last thing it plays is the sound of a human heart beating, a small, defiant rhythm in a warehouse of silence that has finally, at long last, become absolute. You've been watching 10 most disturbing mysteries about the universe that scientists still can't explain. Don't forget to like and subscribe.